Guys, it's me, Mr. Baracus. Hey, what's Baracus doing here? I thought he was supposed to be home, self-isolating. Did you know that Baracus is a YouTuber? He is. Pretty good one, too. Hey, team, welcome to the New World Order and Science 14 online. I'm going to do some class notes with you right now. So these are notes that my substitute was to have done with you way back when, about 2 or 3 weeks ago. So we're a little bit behind on this, but no biggie. This is section 2.2 of your student notes page. And so if you go dig those out, that is what I'm going to be filling out and talking a little bit about as we fill them out. So I'm going to put the page there. I'm going to put me over here. And we are going to talk about the issue of solubility and concentration. Now this is going to be really important because soon you're going to do an activity, an online interactive activity, which is very similar to the lab we would have done if we were in school with real chemicals, but I found a really good simulation that lets you play around with different chemicals and different temperatures without having to wear goggles. But I'm going to wear them just because I'm a science geek and, safety first, right? All right, so solubility and concentration. 2 words that you're going to have to get your heads around, and those are, if you look on the back, there's room for you to write some notes. The 2 ideas you need to know and remember and love are solute and solvent. Okay? Solute and solvent. So I want you to think back about when I added salt to the water and we made ice cream or frozen yogurt. The more solute that you added to the fixture, to the mixture of water, means that the more concentrated the solution becomes. Okay? So solute is the stuff that dissolves. The solvent is the stuff that does the dissolving. Salt and water, salt is the solute, water is the solvent. And more of stuff that you add to dissolve in the water, well, the more concentrated it is. So if lots of one solute is able to dissolve compared to another substance, we say that that substance is more soluble. Soluble. That's the word that describes how much of it can dissolve. We're worried about concentration and solubility because many household products are sold in a very highly concentrated form. So what you do with these things, and I want you to think of, say, who makes frozen orange juice anymore? I don't. I buy the fresh stuff, right? But if you take frozen orange juice or frozen limeade or frozen lemonade, the lemonade or the orange juice concentrate is very, very much more concentrated. You add water to it and you dilute it a little bit. So when you add water, the product, the juice, whatever, becomes more diluted. And why is this important? Well, think about the little can of limeade that you have. There's a can of limeade, and if you read the instructions, you take 1 can of this stuff and 4 cans of cold water to make your juice. You're diluting the concentrated limeade to make something more drinkable. You'd never want to drink this, way too sweet. So when you add water to something sweet, you dilute the sweetness. So there's some examples in everyday life where you dilute stuff. Lime or orange juice is the one I've just brought up. But what about canned soup? What about my favorite canned soup, which is bean with bacon? You add 1 can of this stuff to 1 can of water, and you get 2 cans of soup out of the deal. This is concentrated. What about my daughter's favorite soup? Ugh, cream of potato? Who eats that stuff anyways? My daughter loves this. Canned soup. All right, what else comes in a highly concentrated form? Everyone's talking about disinfecting stuff. This is, if you can read it, there we go, Clorox. This is chlorine bleach. And this comes in a very highly concentrated form. But did you know that you can make a sterilizing solution of Clorox bleach, or of chlorine bleach, Clorox would be the brand name, by adding about 80 mils, that's about that much, 80 mils of chlorine bleach to 4 liters of water, and you've got a disinfecting solution that you can kill germs and viruses with. So Clorox, which is chlorine bleach. Anything else condensed? Anything else that's concentrated? You might look in your cupboard, you may see something called condensed milk. Carnation condensed milk. So bakers will use that for baking as sort of a really thick, goopy milk-like, sweet milk-like stuff. It's really quite yucky and stuff. So why do we bother with concentrated forms of stuff like this and this? Well, it's because when you concentrate it and then you send it out to the consumer, it requires less packaging. Less packaging, okay? And less packaging means that it's lighter and cheaper to ship, less waste, less garbage, benefits everybody. Cheaper to ship, throw less things into the landfill, and so you are good to go. So how do you make stuff like this or this? Well, you got to take the original soup and you've got to try to somehow get rid of, well, if you're adding water, you got to get rid of the water in the first place, right? So products can be made more concentrated by removing water, by removing some of the water. Or, if you want to put it in chemical terms, the solvent. We're taking away, in most cases, water. So this is not a thick soup normally, but if you heat it up slowly, okay, the water will evaporate out and you're going to get a really thick kind of stock at the end of it. So two ways of doing this are through evaporation and distillation. So evaporation is a slow boiling, let's call it. So you're heating up the soup and you're leaving the concentrate behind. Okay, you're heating the soup and you're leaving the concentrate behind. This, even that, okay, that. This is a concentrate. It's a very highly concentrated form. And when you boil away the water or you evaporate the water, you leave a concentrate behind. You can also distill by getting rid of the water by distilling it. Now, in distilling, you still heat, but you're capturing the distillate. So if I were, let's say I was making gin, all right? I'd do my sour mash, I'd ferment all my stuff together, and then I'd heat it up together, and I would heat it up not to the boiling point, but to maybe 70, 80 degrees Celsius, which is the boiling point of the alcohol. And the alcohol is what I want to try to recover in that case. So that's what distillation is. It's boiling away to save or to capture the vapor. So beer companies these days have changed their mode of operation, and I've got a can of disinfectant now that was made in a brewery, and all they've done is they've changed their technique so that they're now, instead of fermenting, they're boiling the fermented mash, capturing the alcohol and turning it into disinfectant, which is way cool. All right. So when making a concentrated product like orange juice, what's happening? Well, there's two things happening. There's something happening to the solute, and there's something happening to the solvent. What is the solute in orange juice? Well, the solute is the orange flavor, all that stuff that tastes good. So the orange stuff. Solvent, oddly enough, is just water. All right? So when you're making a concentrated product, what's happening to the orange stuff? Well, nothing. It's remaining behind. And it's becoming more concentrated. Okay, it's remaining behind. You're boiling the water off and you're leaving behind more and more and more concentrated stuff behind, or soup behind, or chlorine bleach behind, or orange juice or lime juice behind. What's happening to the water? Well, it's just boiling away. So what are you actually doing when you concentrate stuff? Well, you're changing the proportion, the fraction of the solute to the solvent of, say, the orange flavor and the pulp and all the good stuff, the sugars, and the water. So you're changing that proportion. So concentrating a solution increases, if you're concentrating a solution, then it increases the proportion or the ratio of solute to solvent. So a higher proportion of solute means that, well, let's say we start off with, let's say, 25 milliliters of orange and 175 mils of water. Okay? When we're concentrating orange juice, we're taking the water away. So this is becoming the solvent, the solute is staying the same at 25 milliliters, right? Nothing's happening to the orange juice. But we're removing a lot of the water. We're boiling away a lot of the water. Let's say we're taking away 100 mils of that. So if I look at the two proportions here, this is the original. I've got a 25 to 175 ratio, or a 1 to 7 ratio of orange juice to water. All I've done is I've divided 25 and 175 by 25. So 25 divided by 25 is 1. 175 divided by 25 is 7. When I concentrate, I'm changing the ratio or the proportion to this, aren't I? And when I simplify that fraction, it becomes 1 to 3. So there's your two proportions. There's your two ratios. There's the simplified proportions. This is concentrated. This is concentrated. This is dilute. This is the drinking stuff. Obviously, this container, if I'm selling concentrated orange juice, it can be much smaller, have less packaging, be much less expensive to send around. And so this is preferred. So that's your mini lesson on solubility and concentration and why we do it. You should have a couple of take-homes here. You should understand that when you concentrate something, you're changing the ratios of the solute to solvent. You should understand that you are reducing the amount of stuff that you have in it. So if you're concentrating orange juice, instead of 1 liter, you're going to have maybe 250 mils, much less. And you are therefore reducing packaging, and likely you're also reducing the transportation cost to get it around. And I've just lost my finger, but you know what? Here it is. Okay? So this big idea of chemistry and solubility and concentrations and all that stuff has practical purpose, which is why we're showing it to you now. So you understand how you can make choices that will that'll help the environment, that'll help reduce waste, and help even save you money. Because concentrated orange juice is going to be a lot less, won't taste the same, but it'll be a lot less than undiluted fresh orange juice, which tastes better. All right, that's your lesson on solubility and concentration. Go forth and take a look at the lab I've set up for you. You'll find it right, well, it's either there or it's there. It's one of those two places. Cheers, take care, catch you on the flip side. Stay safe, wash your hands. Disinfect with Clorox bleach solution. Cheers. Oh, and safety first.